students, welcome to the video past examination paper solving mathematics 9709 A-level mechanics paper 42 May June 2024. Question number 1. A cyclist and bicycle have a total mass of 72 kg. The cyclist rides along a horizontal road against a total resistance force of 28 newtons. Find the total work done by the cyclist to increase his speed from 8 meters per second to 16 meters per second while traveling a distance of 100 meters. So work done, actually our aim is to find the work done. Initial speed is 8 meters per second, final is 16 meters per second as it is mentioned in the question, and the displacement or distance traveled here is 100 meters. Now, first, using this formula, we can find V2 minus U2 is equal to 2AS, where S represents the displacement. We can find acceleration of the bicycle. So, final velocity is 16 squared minus initial, which is 8 squared, is equal to 2. A is unknown times displacement, which is 100 meters. Now, solving this equation, it will be giving us 0.96 meter per second squared as the acceleration. Now, applying the second Newton's law, for example, it is the bicycle. Now we have driving force, then we have resistance, which is the opposite direction. So applying the second Newton's law, we have driving force minus resistance, which is given in the question, 28 newtons is equal to MA. M is the total mass is 72, and acceleration of the bicycle and the cyclist total in total is 0.96. So driving force here will be 72 times 0.96 plus 28. Hence, driving force will be 97.12 newtons. Now, in order to find the work done, so work done by the bicycle, by the cyclist will be actually driving force times the displacement, distance traveled. So it will become driving force, which is 97.12 times the total distance traveled by the cyclist is 100 meters. So it will be 9712 joules is the total work done by the cyclist. Question number 2. A particle P moves in a straight line at time t seconds after leaving a point O on the line. P has velocity v meter per second, where v is equal to 44t minus 6t squared minus 36. Part A, find the set of values of t for which the acceleration of the particle is positive. Part B, find the two values of t at which p returns to O. Okay. For the first part, we know that acceleration is equal to rate of change of velocity with respect to time, and it's supposed to be positive. So let's first find dv dt. dv dt will be 44 minus 12t is supposed to be positive. So minus 12t is greater than minus 44. So t, when you divide by negative, you remember that you should change the orientation. So it will be 44 over 12. So t is less than 11 over 3. In this interval, acceleration is positive. Part B, find the two values of t to which p returns to origin. It means that displacement should be 0. We know that displacement is integration of actually v velocity with respect to time. So it will be equal to integration of 40 minus 6t squared minus 36 dt. So it will be equal to 44 t squared over 2 minus 6 t cubed over 3 minus 36 t plus c. So it simplifies to 22 t squared minus 2 t cubed minus 36t plus c. We know that when t0 is 0, so c will be 0 as well. So this is our displacement. So displacement is to be 0. So 22 t squared minus 2 t cubed minus 36t is supposed to be 0. So I factor t, and you can factor 2 also. So it will be 11t minus t squared minus 18 is equal to 0. So solving this equation, so once t is equal to 0 is one of them, so it is the initial time. So the other one is minus t squared plus 11t minus 18 is equal to 0. I multiply by negative, it will be t squared minus 11t plus 18 is equal to 0. It is factorized to t minus 9, t minus 2 is equal to 0, t is equal to 9, t is equal to 2. These are the two acceptable answers. Question number 3. For coplanar forces of magnitude p Newton, 10 Newton, 16 and 2 Newton act at a point in the directions shown in the diagram. It's given that the forces are in equilibrium. Find the values of theta and p. Okay, now let's resolve forces both horizontally and vertically. This force can be written as 10 cosine of 25, and this is opposite, so I write it here. So this is 10 sine of 25 degree. This force, I resolve this force, so it is 2 cosine of 40. Then if I horizontally resolve this force, this is opposite, so this force will be 16 sine of theta. So I write horizontally first. So horizontally we have 10 cosine of 25 is supposed to be equal to the forces in the opposite direction. So it will be 2 cosine of 40 plus 16 sine of theta. If I make theta the subject, so theta will be sine inverse of 10 cosine of 25 minus 2 cosine of 40 degree over 16, giving you an answer of 28.1 degree. It is the value of theta. Now to find p, now I resolve vertically. So upwards you have p, here in this direction you have, this is opposite, we wrote 10 sine of 25, this will be 16 cosine of theta, this will be here will be 2 actually it is opposite to 40, so it will become this vector 2 sine of 40. So upwards we have p, downwards we have this vector which is 10 sine of 25 already written, this vector it is written here 2 sine of 40, and this is, which is adjacent for this theta, is 16 cosine of theta. So p is always should be equal to the sum of all the vectors in opposite directions. So it will become 10 sine of 25 plus 16 uh, cosine 25 plus we have another vector 2 sine 40, which will be equal to 19.6 newtons. Question number 4. A car has a mass 1400 kg. When the speed of the car is v meter per second, the magnitude of the resistance to motion is kv squared newton, where k is a constant. Part A, the car moves at a constant speed of 24 meter per second up a hill inclined at an angle of alpha to the horizontal, where sine of alpha is 0.12. At this speed, the magnitude of the resistance to motion is 480 newton. The first part, find the value of k. The second part, find the power of the car's engine. Part B, the car now moves at a constant speed on a straight level road. Given that its engine is working at 54 kilowatt, find this speed. Okay, for the first part, as it's given that resistance is 480 and is equal to kV squared, so R is equal to kV squared. R is given 480 newtons is equal to k, which is unknown, and the speed is given, which is 24, so s squared. So k will be 480 over 24 squared. So it simplifies to 5 over 6 as a constant number. For the second part, I construct. So it's a car. We have driving force, which has upward direction, resistance opposite, and here we have also mg sine alpha. This is the angle alpha. So we have driving force of the hill, driving force minus, we have resistance, which is 480 minus mg sine alpha. M is 1400 times g10 times sine alpha is 0.12. As it's moving at a constant speed, so acceleration is 0, so ma will be 0. So driving force will be equal to 480 plus 1400 times 10 times 0.12, which is 2160 newtons. But it wants you to find the power. Power will be Fv, so driving force, which is 2160 times speed, which is 24, giving you an answer of 51,840 watt, which is approximately equal to 52 kilowatt. Now for B, the car now moves at a constant speed on a straight level road. So now we have this situation. So it is car, for example, it is driving force, and opposite direction we have resistance, and A is 0. Now it says given that its engine is working at 54,000 watt, find this speed. Now we know that driving force times V will be equal to power, which is 54,000, and acceleration is 0. So when acceleration is 0, it means that driving force is equal to resistance. Now here resistance. If I write here instead of driving force, I write 54. I make actually driving force the subject 54,000 over V is equal to resistance. Then we know that resistance is kV squared, and K was actually resistance was kV squared. So resistance is equal to 5 over 6 V squared. So combining these two, um, so 5 over 6 V squared is equal to, we know that resistance is equal to driving force. So driving force is, this is resistance, and here driving force, which is 54,000 over V. So V cube will be equal to 6 times 54,000 divided by 5. So taking the third root, V will be equal to approximately 40.2 meter per second. Question number 5. A particle of mass 0.8 kg lies on a rough plane which is inclined an angle of 28 degrees to the horizontal. The particle is kept in equilibrium by a force of magnitude T newtons. This force acts at an angle of 35 degrees above a line of greatest slope at the plane C diagram. The coefficient of friction between the particle and the plane is 0.2. Find the least and greatest possible values of T. Let's first resolve our forces. So we have here T cosine of 35, here which is normal contact force R, and this is this vector with respect to this angle will be opposite. So I write it here. This will be T sine 35. Downwards we have mg sine 28 degree, and we have also friction. Then I will decide about the friction. Here we have mg, and here we have mg cosine of 28. Now, for the maximum case is the case when it is about the object is about to move upwards, so friction has opposite direction, this direction. So if I write Newton's second law, so it will become T cosine of 35 minus mg sine 28 degree minus friction, which is mu r, is 0. So in order to find r, now we know that r plus t, here it is sine of 35 is equal to mg cosine of 28. So r will be mg cosine 28 degree minus t sine 35 degree. So I replace here, it will be t cosine 35 degree minus mg here sine 28 degree minus mu times mg cosine of 28 minus t sine 35 degree is equal to 0. So I replace the values. It will become t cosine 35 degree minus m is 0.8 times 10 times sine degree minus mu, which is 4.2 times m, uh, which was 0.8 times 10 times cosine 28 minus, again mu times this, which will become then positive 0.2 times t times sine 35 degree is equal to 0, and making t the subject, it will become 0.8 times 10 times sine 28 degree, um, here plus 0.2 times 0.8 times 10 times cosine 28 divided by, here coefficient of t is cosine 35 plus 0.2 times sine 35. Calculating this amount, it will become 5.53 newtons as the T max. Now for the least possible value, we assume the case where the object is about to move downwards under its weight. So friction will be actually in the opposite direction, which is upwards. So we have T cosine 35 plus friction, which has the same direction as T cosine 35, mu r, minus mg sine 28 is equal to 0. So it will become T cosine of 35 plus mu, which is 0.2, or we found it in the previous part, which is mg cosine 28 minus t sine 35 minus mg sine 28 is equal to 0. After calculating this and making t the subject, t will be 3.33 newtons as the least possible value of t. Question number 6. Three particles A, B, and C of masses 5 kg, 1 kg, and 2 kg respectively lie at rest in that order on a straight, smooth, horizontal track x, y, z. Initially, A is at x, B is at y, and C is at z. Particle A is projected towards B with a speed of 6 meters per second. At the same instant, C is projected towards B with a speed of v meter per second. In the subsequent motion, A collides and coalesces with B to form particle D. Particle D then collides and coalesces with C to form particle E, and E moves towards Z. Part A show that after the second collision, the speed of E is 15 minus v over 4 meter per second. Part B, the total loss of kinetic energy of the system due to the two collisions is 63 joules. Use the result from part A to show that v is 3. Part C, it's given that the distance xy is 36 meters and the distance yz is 98 meters. Find the time between the two collisions. The second part of part C, find the time between the instant that A is projected from X and the instant that E reaches Z. Okay. For the first part, actually A is projected towards B and C is projected towards B as well. Now, so a speed of mass of A is 5 kg and the speed is 6. So 5 times 6 mv of actually particle A plus B is at rest, so 0 is equal to then they collide and coalesce to form a particle D. So the total mass of the particle D will be 5 plus 1, the mass of A plus B together. So it will be 5 plus 1 times speed of particle D. So V of D will be 5 meter per second. Then, so particle D will have a mass of 6 times speed of D, which is 5, is moving towards, right. Then E has, C has opposite direction, which is going to collide with particle D. So it will be minus mass of C is 2 and the speed is V is equal to, then the, they collide to form a particle E, which will have a mass of 5 plus 2 plus 1, then a speed of E. So speed of E will be equal to 30 minus 2V over 8, which simplifies to 15. They are divisible by 2 minus V over V meter per second. For the second part, it says the total loss of kinetic energy of the system due to the two collisions is 63 joules. Use the result from part A to show that V is 3. So final kinetic energy will be equal to half of m, because it is mass of E after the two collisions, will be equal to 5 plus 2 plus 1 V squared, and V of speed of particle E is 15 minus V over 4 squared. Then initial kinetic energy will be equal to half of a mass of A, which is 5, speed was 6 squared, plus half of, for C will be times 2 times V squared, so it will be equal to 90 plus V squared. So as it is, we have loss, so it means that final kinetic energy, which is 1 over 2, 5 plus 3, 8. 8 divided by 2 will be 4, 15 minus V over 4 squared minus initial one, which is 90 plus V squared, is supposed to be negative 63. As it is lost, it is negative. So solving this quadratic equation, V will be 3 meter per second. For the next part, it says it's given that the distance xy is 36 meters and yz is 98 meters. Find the time between two collisions. Now, A is moving at the speed of 5, sorry, 6 meters per second. So, because it's moving at the constant speed, so S will be Vt. So displacement is 36 is equal to V, which is 6 times T. So T will be 6 seconds. After 6 seconds, A actually collides with B. Then, but C has been projected towards B at the same instant. So after 6 seconds, C also has been moving towards B. So let's see how much. Speed of C was 3. So 3 times 6 will be 18 meters. It means that after 6 seconds, C will be, somewhere here, for example, 18 meters forwards towards B. So now we have the new situation. A and B coalesce to form D. Here we have object C. Now the initial distance was y to z 98 meters, but C now is 18 meters closer to B. New distance will be 98 minus 18, which is 80 meters. Now, speed of D was 3, sorry, we found it was 5. So 5t plus now speed of c is 3, so 3t. So the total displacement, they are supposed to collide here, I mean somewhere between, which is 80 meters. So the total, the sum of their displacements should be 80. So 8t will become 80. So t will be 80 over 8, which is 10 seconds. Now part C, second part, find the time between the instant that A is projected from X and the instant that E reaches Z. Now we know that it took 6 seconds for the particle A and B to collide. And after 6 seconds, we know that particle C was 18 meters from point Z. And it took 10 seconds for particle C and particle D, which is after collision of particle A and B, to collide for the second time, for the second collision actually. So 10 seconds times the speed of C was 3, so 30 meters. So it means that apart from these 18 meters, C has moved 30 meters more. So the distance of, it is point Z. Now it is 18 plus 30, which is 48 meters for the collision to form particle E. So it means that particle E is 48 meters from Z. And we found that speed of particle E was 15 minus V, which is 3, speed of particle E, 15 minus 3 divided by 4, which is 3 meter per second. So now the distance between particle E and point Z is 48 meters and the speed is 3, constant speed. So time taken for particle E to reach Z is 48 over 3, which is 16 seconds. Now, we had 6 seconds initially for particle A to and A and B to collide. Then it took 10 seconds for particle C and D to collide to form particle E, and it took 16 seconds for particle E to reach Z. So the total time will be 6 plus 10 plus 16, which is 32 seconds. Question number 7, two particles P and Q of masses 2.5 kg and 0.5 kg respectively are connected by a light inextensible string that passes over a smooth pulley fixed at the top of a plane inclined at an angle of 30 degrees to the horizontal. Particle P is on the plane and Q hangs below the pulley such that the level of Q is 2 meters below the level of P. See the diagram. Particle P is released from rest with the string taut and slides down the plane. The plane is rough with coefficient of friction 0.2 between the plane and P. Part A, find the acceleration of P. Part B, use an energy method to find the speed of the particles at the instant when they are at the same vertical height. For the first part, A, we use the Newton's second law. So in this direction, we have mg, which is 2.5 g10 sine of 30 for particle P, sine 30, then minus friction, which is opposite direction, mu r, minus it is actually opposite direction, 0.5 times 10 is equal to the total mass, which is 2.5 plus 0.5, 3a. Now it will become 2.5 times 10 times sine 30 minus mu, which is 0.2 times r, is actually mg, which is 2.5 g 10 times cosine of 30 minus 0.5 times 10 is equal to 3a. After solving this equation, a will be 1.06 meter per square seconds. For part B, use an energy method to find the speed of the particles at the instant when they are at the same height. Now, uh, we know that P is here. Now, this angle is 30. Assume that P moves y meters downwards to come here. Now, Q also moves upwards y meters. Now, if it moves y meters up, we know that the initial distance between their heights was 2 meters. So this distance will be 2 minus y meters. So forming a right angle triangle, we know that this angle is also 30. This Q and P are supposed to be at the same height. So this is 2 minus y. Then we have opposite hypotenuse. They form a right angle triangle. So we can write sine of 30 is equal to opposite over hypotenuse. Sine of 30 is half. So half y is equal to 2 minus y. So if you transfer to the left hand side, it will become 3 over 2y is equal to 2. So y will be 4 over 3 meters. So this is 4 over 3 meters. Now this distance will be 2 minus 4 over 3, which is then 2 over 3. Now let's use energy method. For Q, I write change in potential energy. So it will become 0.5 mgh half, g is 10, height, it moves 4 over 3 meters up, so times 4 over 3. For object P, delta potential energy will be equal to m, which is 2.5 times g times, now it moves vertically, it is 2 over 3. Now 2 over 3, but negative 2 over 3 because it comes down. So it will become 2.5 times 10 times negative 2 over 3. Now let's write change in kinetic energy will be equal to for object Q, it will become half of m v squared, and plus for object P, half of m, which is 2.5 times v squared. We don't have v, so it will become 2.5 plus 0.53, half of 3 will become 1.5, so it will become 1.5 v squared. This is changing kinetic energy. Now we have friction here. Work done by friction will be equal to F d, friction is mu r times d, so it will become mu, we have the 0.2, r is mg cosine, m is 2.5, g10 cosine of 30, times it was then distance traveled it is y meters, which is 4 over 3. It moves 4 over 3 meters down, then along the actual plane. Then we wrote d also, so it will be at the end. We know that change in mechanical energy will be equal to work done by the friction here. So change in mechanical energy. we have some of these two potential energies. It will become minus 10 plus change in kinetic energy 1.5 e squared is equal to work done by the friction, which simplifies to here minus 10 root 3 over 3. Then solve this equation, so we will be equal to 1.68 meters per second as the speed of the particles.